Hello, I'm Sritoma. I suppose I'm a big fan of science, and I hope you are a big fan of science too. So, what better way to learn science than to do an experiment? So, for today's experiment, we have some colored water, a small container, some aluminum foil, a safety pin, and some thread. So, we'll get to air pressure soon, okay, don't worry about it. But let's first do the experiment. So, first, take the small container, and we just don't need a cap. And let's just squeeze the container and put in the colored water and take it out. You see that? The whole thing goes up. Even if I just place some aluminum foil over here, and this will look somewhat like a syringe to you, probably. So if I place this here, just look at this. So if I just place this here and wrap the aluminum foil around that open part and tie the whole thing like this. And if I poke a hole at the top, okay, you just want it so that knot doesn't open. So I'll tie a tighter knot, somewhat like this. Now we wanna poke a hole at the top so that the water could get in. And then we'll again squeeze the whole thing, put in water, and again let go of the whole thing. You can see that it again soaks up some water, but it soaks up lesser water, right? Yeah, it soaks up more water. Okay, so this structure is somewhat like a syringe. You can say it's like a syringe, kind of. But why didn't it work for both of them? Of course, you might think that since we put this aluminum foil all over here, it prevented the water from, getting out. But what made the water move in the first place? Well, it's time to keep all this aside and talk about air pressure. Okay. So, when you took the container, you can see that there's some air inside this whole thing. And, air exerts pressure on everything. But air exerts a huge amount of pressure on us. That quantity of pressure that it applies on us is huge. But why don't we feel this pressure? Well, that's because our body applies the same amount of pressure as the air around us pushes on us. I mean, the amount of pressure the air around us applies on us. So the air in our body exerts a pressure so that the pressure outside and the pressure inside get cancelled. So we do not feel anything. So there is some amount of air inside, and it exerts a pressure on, every single thing that is air around it. or at least a gas around it, or just, well, matter around it. So, the moment you squeeze the whole thing, you can see that I'm squeezing the whole thing. The moment you squeeze the whole thing, air goes out, right? But still, the container can take less air, so, well, nothing is going to happen. When you put the whole thing into water, and then nothing will happen again. But the moment you release the whole thing, it's like the size of the container slightly increased. Because it's almost like the size of the container slightly increased. I mean, the volume of within the container just increased, right? So the amount of air in cannot escape, well, you know that, and air cannot enter as well, because it has to push the water down to get inside. And that's exactly what happens. Air wants to move inside, so it pushes the water down. And when the water gets pushed down, the water gets pushed into the little container, thus making the water move in. Now when you lift it above and look at it, the water still doesn't flow out or leak out of the whole thing. The moment you take it out, the same thing, the same logic can be applied to this as well. You see, the moment you sucked it in, nothing happened to the amount of air inside, right? So the amount of air inside still remained a little less. So when you took it out, water is heavier than air, you know that. And so it's a little confusing to think of water as just staying here. But I'm going to prove something to you. Something amazing. Well, amazing if you don't know it yet. If you take a little bit of water, it doesn't stay in the container for long. As if you take just about a drop of water, it doesn't make sort of that blanket of water that used to make sure the air can't flow into the container. Okay? So, the air is continuously trying to get inside of this container, but it has to make sure it can, cause a hole in this blanket of water that makes it such that it can't enter this whole thing. So it just pushes the water up. So the water does not flow out of the whole thing. Get it? When you put in the aluminum foil, it gives it a little extra security, so it doesn't leak out of the whole thing. Excuse me. So I hope now you understand why, if you take a little container, plastic container preferably, because you can squeeze it. So squeeze it tight, put it in the water, let go of the whole thing, pick it out. You have some water above, the ground. But this is a little confusing. See, when I touch the whole thing with this, the whole thing still doesn't leak out. So I know it's a little confusing. Also, just to do another experiment. Observe, even if I do this, the water doesn't leak out. So cool. Even if I keep it at this slight angle, the water again does not leak out. But there's one little dicey part to this. When I keep it at an angle great enough, you will see that the water eventually starts to flow. Okay, I need to let some water go. Okay, so I have lesser water here, and now if I keep it at an angle somewhat this much, okay, you will see that the water starts to flow. Now, why does this happen? Well, you're simply giving it a chance. You're simply giving the air around you a chance to get inside the container. And the water being heavier, falls down. Matter, which is denser than the matter around it, sinks down or falls down. And we can say that we unlocked our mystery. But I want you to observe something. If I take the safety pin and if I make it go all the way through, the water still doesn't drop down, or at least trickle down or fall down. So what's happening right here? The water is still a liquid. So what just happened? Figure this out. I'll leave that as a question for you. This experiment is a very easy one and I hope you try this at home. Goodbye.